Hey guys, Midecali here. Welcome back again. Today, under Fundamental of Electric Circuits, we are going to be looking at KCL and KVL, which is Kirchoff Current Law and Kirchoff Voltage Law. Kirchoff Current Law states that the sum of current entering into a node is equal to the sum of current leaving a node. You see that word node, underline it. That's a very key word in defining or stating the law of KCL. While for KVL, it states that the algebraic sum of voltage in a closed circuit or a loop, the word loop, is equals to 0. So I'm going to write it now saying that the algebraic sum of current entering into a node is equals to the algebraic sum of current leaving a node. And this one states that the algebraic sum of voltage in a loop is equal to 0. So we'll be solving this equation. We'll be dealing with what's on the screen here. Let's divide our page into 2. So first of all, let's deal with our KCL. Remember I told you to always look at your node. So this is a node, right? This is a node, this is a node, but we can't do that. That's wrong. We circle it all as one node. So that's our node, right? And they're telling us the total current travels this way. This arrow tells you where direction of current. So remember, whenever a current is going into a loop, it's positive. But whenever the current is going the arrow direction of current is against the loop, that's negative. So looking at this, our total current IT is equal to, right? Our total current IT is equal to, look at our I1. Is that arrow facing this node? No, it's facing down. It's facing this direction. So we have it to be minus I1. Then look at our I2. The arrow is facing the node, right? So it's positive, right? How about our I3? Positive as well, because it is facing the direction of the node. And our I4 is negative. So to make things easy for you, we know these guys are leaving, and these guys are entering and entering. We could also continue with this equation by saying IT, bringing this over to the other side, plus I1 plus I4 is equal to I2 plus I3. States that in is equal to out. So these are the current equals to this current. I just brought like terms to one side. These negative guys cross to this side, so we can all be positive equals to positive. That's what I did here. So coming to KVL. Now there's something I need you to know. You see these signs, these polarity signs, they matter. They affect voltage V and current I, but for your resistor it's always positive. So in this case where we have minus here and positive here, imagine we're traveling from this direction, current was traveling in this direction, we have it to be negative. If current was traveling to this direction, we have it to be positive. So these polarity signs, they affect just your current I and voltage V, but they never affect your R, because R is always counted or noted as positive. So let's read what is happening in this loop. Always travel clockwise. Though you can travel anti-clockwise too, but it's just always advised to go clockwise. And remember, whatever direction you go in a loop, you have to go all through in other loops. Imagine if we had like 3 loops here. So because in this our loop 1, we went this way, in our loop 2, we must go the same direction, the same direction, the same direction. Don't forget to that. So reading this loop, when we travel in this direction. Let's start from here. When we are coming from this direction, what do we hit first? We hit the negative sign, so we say minus V1. So we exit here, we come to V2. What sign do we hit first? Positive. Plus V2. We exit. What do we hit first here? We hit plus V3. When we exit, what sign do we hit here first? Minus V4. When we get here, what sign do we visit here? Plus V5 is equal to 0. Sum is equal to 0. So let's collect them to have positive, positive, positive is equal to minus positive V1 now, and positive V4. Remember, I told you this is resistor, this is also sign of resistor. So if you can know this, by the time we get into equations, you would obviously know how to travel through a loop and how to calculate current. So for this exact KCL, you could in as much as well go this way. You circle this point as our node, right? So this is our I1. I1 was traveling away from our node, right? I1. Our I2 was traveling into our node. Remember, our I3 was going what direction, as well as into our node, and our I4 was going what direction, against our node. So this is another way in which you could use to simplify. So therefore, these guys are entering, they are in, and these guys are out. So that is why we have I1, I4 on like terms, and our I3, I2 on like terms. Thank you very much, and subscribe.